In the darkness of deep space, more than 10 billion years away, there is a single point of light hiding something almost impossible. It looks small from Earth, just a faint glow in the cosmic distance, but buried inside that light is one of the most extreme objects ever discovered. A black hole so massive, it has been estimated at 66 billion times the mass of our Sun. Not 6 million, not 6 billion, 66 billion suns. Its name is TON 618, and the mystery is not only that it exists. The real mystery is how the universe could have built something this massive at all. Because when astronomers look at this distant object, they are not just seeing a black hole. They are seeing a question written in ancient light. How did something this big form so early in cosmic history? And what else is hiding out there, waiting to be found? This cosmic monster is not something we can see the way we see a planet, a moon, or a star. A black hole itself gives off no light. Once light crosses the event horizon, it cannot escape. So when astronomers study this object, they are not looking directly at the black hole. They are studying the storm around it. TON 618 is seen as a quasar, an intensely bright galactic center, powered by a feeding supermassive black hole. Gas and dust swirl around the black hole at incredible speeds. Before that material disappears forever, it heats up and shines with terrifying brightness. That light travels across the universe, across billions of years, across expanding space, until finally it reaches our telescopes here on Earth. And hidden inside that light is evidence of something enormous, something so powerful, it turns the center of a distant galaxy into a cosmic beacon. To understand why this black hole is so shocking, we have to talk about scale. Our Sun is already enormous. You could fit more than 1 million Earths inside it. At the center of our own Milky Way galaxy is a supermassive black hole called Sagittarius A star. It has a mass of about 4 million suns. 4 million suns sounds impossible to imagine, but next to this distant giant, even that becomes small. This object is not measured in millions of suns, it is measured in tens of billions. That means this one black hole may be thousands of times more massive than the black hole at the center of our galaxy. And this is where the numbers begin to lose meaning, because it is not simply big, it is big in a way that challenges the mind. A black hole this massive would have an event horizon so vast that it would stretch across a region larger than our solar system. If you tried to picture it beside the sun would not look like a star anymore. It would look like a speck, and this black hole would look like the dark center of a cosmic machine. But the size is only the beginning of the mystery, because black holes do not become monsters instantly. To become this massive, a black hole has to grow. It has to pull in gas. It has to tear apart stars. It may have to merge with other black holes. And over enormous stretches of time, it feeds on the material around it. That is where this object becomes strange. Because it is so far away, we are seeing it as it was billions of years ago. The light reaching us today began its journey when the universe was much younger. So, astronomers are not seeing it as it is right now. They are seeing an ancient version of it, and that ancient version was already enormous. That creates a problem. A black hole needs time to grow, but this one appears to have become a monster when the universe had far less time to build one. So the question becomes uncomfortable. Did it grow faster than we thought possible? Was it born from a massive seed? Did it feed under conditions we do not fully understand? Or is it a clue that the early universe was far stranger than our models suggest? Of course, no one has placed TON 618 on a cosmic scale. No telescope has flown close to it. No spacecraft has measured it. Everything we know comes from light. Astronomers study the glow coming from the quasar. Then they break that light apart into a spectrum. Inside that spectrum are clues. Certain lines in the light can reveal how fast gas is moving around the black hole. And when gas is moving at extreme speeds, it means something with extreme gravity is controlling it. The faster the gas moves, the stronger the gravity must be. And the stronger the gravity, the more massive the black hole may be. This is how scientists can estimate the mass of something they cannot see directly. They read the motion of matter around it. They study the light that escaped before the material vanished forever. In a way, this black hole is invisible, but its gravity leaves fingerprints, and those fingerprints point to one of the largest black holes ever observed. Now the mystery becomes even deeper. How does a black hole grow to tens of billions of solar masses? There are only a few possible answers. One possibility is that it began as a much larger seed than ordinary black holes. Maybe it did not start from the death of a single massive star. Maybe it formed from the direct collapse of a huge cloud of gas in the early universe. Another possibility is that it fed at an extreme rate. A black hole can grow by pulling in surrounding gas and dust, but there may be limits to how fast it can feed before the energy blasting outward pushes material away. So if this object grew so large, perhaps it had access to a massive supply of gas, or perhaps it went through periods of unusually rapid feeding. A third possibility is mergers. Galaxies collide, black holes sink toward the center, and over time, smaller black holes can combine into larger ones. But every answer creates another question. Where did the fuel come from? How long did the feeding last? How many mergers would it take? And how did all of this happen so early? This distant giant does not just ask us to explain one black hole. It asks us to explain the conditions that made it possible. The early universe was not calm. It was younger, denser, and more violent. Galaxies were forming. Gas was collapsing. Stars were being born in enormous numbers. Gravity was pulling matter into structures that would eventually become the galaxies we see today. In that ancient environment, black holes may have had opportunities that are rare today. There may have been more gas available, more collisions, more chaos, more chances for massive objects to grow quickly. So perhaps TON 618 is not a mistake. Perhaps it is a fossil from a more violent age, a time when the universe was better at building monsters. But that idea is both exciting and disturbing. Because if the early universe could build something this massive, then maybe this black hole is not alone. Maybe there were others. Maybe there still are. Hidden behind dust, hidden inside distant quasars, hidden so far away that their light has barely reached us. This object may not be the final answer. It may be the clue that tells us where to look next. There is another strange part of this story. This quasar is so bright that it hides the world around it. The light outshines much of its surrounding galaxy. That means the very thing that allows us to detect it also makes it harder to understand. It is like trying to study a city by staring directly into a spotlight. You know something is there. You know it is powerful, but the brightness overwhelms the details. This is one reason objects like this are so difficult. They are distant, they are ancient, they are extreme, and they are surrounded by uncertainty. Astronomers can estimate their properties, but every estimate depends on clues carried by light across billions of years. This black hole is not sitting in our cosmic backyard. It is not close enough for a clean, simple view. It is a monster seen through distance, time, and glare. And somehow, even through all of that, it still appears enormous. That may be the most unsettling part. The evidence is difficult. The object is distant. The details are hard to see, and yet the conclusion remains staggering. Something unbelievably massive is real. This is why TON 618 matters. Not just because it is large, but because it sits at the edge of what we understand. Its size forces a bigger question. How do supermassive black holes form? And how quickly can they grow? Do they simply live inside galaxies, or do they help shape them? And in the earliest ages of the universe, did black holes begin growing sooner than scientists once expected? For a long time, black holes were thought of as cosmic endings, places where matter disappears. But modern astronomy has shown something different. Black holes can also be engines. They can power quasars. They can launch jets of particles across enormous distances, and they can influence how stars form around them. So when we study TON 618, we are not just studying one black hole. We are studying a piece of the universe's construction history, a clue from a time when galaxies were still young, a signal from an age when cosmic structures were still forming, a reminder that the universe may have built its most powerful engines earlier than expected. TON 618 is not just a black hole. It is a challenge to our timeline, a challenge to our models, and a challenge to the idea that we already know how the universe grew up. And then comes the final question. If something like this exists, what else is out there? Every generation of astronomy has found objects that seemed impossible at first. Stars larger than expected, galaxies farther than expected, planets in places where we did not expect planets to survive, and black holes that keep pushing the limits of what we thought could form. The universe has a way of making our biggest ideas look small. This distant giant may be one of the largest black holes we know about, but that does not mean it is the largest that exists. It may simply be one of the largest we have found. There could be others even farther away, others hidden behind dust, others no longer shining as quasars, others waiting in old galaxies, silent and dark. The most frightening monsters in the universe may not be the ones we can see. They may be the ones that have stopped feeding, the ones that no longer glow, the ones that sit quietly in the centers of galaxies, invisible until something gets too close. This black hole shines because it is active. Material around it is giving away its location, but a sleeping giant would be much harder to find. And that means the universe may still be hiding black holes even more mysterious than this one. This black hole began as a faint point of light in the sky, but inside that point is a story about gravity, time, and the limits of human understanding. A black hole so massive that it turns imagination into mathematics. A quasar so bright that it hides the galaxy around it. A cosmic engine from the ancient universe, asking a question we still cannot fully answer. How did something this big form so soon? Maybe it is rare. Maybe it is an extreme accident of cosmic history. Or maybe it is a warning. A sign that the universe was building monsters long before we thought it could. And if that is true, then this is not just one of the biggest black holes ever observed. It is a doorway into a deeper mystery. Because somewhere beyond the reach of our clearest telescopes, there may be other giants. Older, darker, larger, waiting in silence. This is Hidden Science Stories, and the universe still has secrets